All right, today we're going to do something that sounds like it's straight out of science fiction. We're going to grow a plant from the ground up, but here's the twist. We won't be using a single drop of water or a speck of soil. We're going to use code.
So, think about this for a second. How would you grow the perfect plant? I mean, optimize its every single need, predict its final weight down to the gram, all without ever getting your hands dirty? Well, that's the powerful question that this kind of simulation technology is finally starting to answer.
So here's the game plan for how we're going to build this thing. First, we'll lay out the blueprint for our digital plant. Then, we'll mix up the recipe for its growth. We'll peek into its daily diary as the simulation runs, check out the final harvest report, and then we'll talk about why any of this really matters.
Okay, let's dive right in. First up, creating the blueprint. Just like building a house, you can't just start throwing up walls. You've got to have a solid plan.
In the coding world, that plan has a name. It's called a data structure. And honestly, the best way to think about it is exactly like an architect's blueprint. It's not the house itself, right? It's the detailed set of instructions that tells the program precisely what information it needs to keep track of and how all those pieces are supposed to fit together. It's the absolute foundation for everything we're about to do.
And for our simulation, these blueprints are made using something called data classes. You could just think of them as these super clean, simple files that let us define, well, everything about our virtual farm, from the tiniest root on the plant to the weather patterns for the whole season.
Okay, so our blueprints are drawn. Now it's time to gather the ingredients. Every simulation has to start with a recipe to get things going.
And the master recipe for our whole operation is called hydro input data. Think of it like the main command center that pulls together all the starting conditions. It takes 3 of our core blueprints and combines them to set the entire stage before the very first virtual day even begins.
So what's in this recipe? Well, it's actually pretty straightforward when you break it down. First, you've got the physical setup, the system. How big is the water tank? What kind of hydroponic system are we using? Next, of course, you need the star of the show, the crop. What are we growing? What are its key characteristics? And finally, what's the environment like? That's the weather. Is it hot, cloudy, sunny? With those 3 things defined, our virtual world is officially ready to go.
All right, the blueprints are done, the recipe is set. Now for the fun part. Let's run the simulation. The best way to think about this next piece is like our plant is keeping a daily diary, recording absolutely everything that happens to it every single day.
And I'm not kidding when I say daily diary. This isn't just, hey, did I grow today? No. The simulation is tracking over 100 different metrics every single day for just one plant. That's like giving it a complete physical with full lab work every 24 hours. It's incredible.
So this super detailed diary is all handled by a data class called DailyResults. And yeah, tracking over 100 things sounds kind of crazy, right? But it's actually really organized when you break it down into a few key areas.
First, let's look at the plant's engine. We're talking about photosynthesis. How is it making its food? Is it being held back by a key enzyme, or is it just not getting enough light? And then, on the flip side, respiration. How is it using that energy? Is it just for basic upkeep, or is it being funneled into building new leaves and roots?
Okay, next up, we're tracking its actual physical growth. How much bigger is it getting? That's the total biomass. But what's really cool is that it also models its shape, its architecture. It's not just tracking total leaf area. The simulation is smart enough to know the difference between the leaves soaking up the sun and the ones hiding in the shade, because that completely changes the plant's energy game. And finally, we're keeping an eye on the plant's overall health and well-being. The simulation tracks all the nutrients like nitrogen to see if it's being used for new growth right now or being stored away for later. And this is the really critical part. It acts as an early warning system. It's constantly calculating these stress factors, telling us if the plant is getting too hot or if it's running low on food.
So day after day, our simulation runs, and it's just generating this mountain of data. How in the world do you make sense of all that? Well, that's where the final harvest report comes in.
See, the program has one last trick up its sleeve, a final blueprint called the SimulationResults class. And its only job is to scoop up every single one of those daily diary entries we talked about and put them into one neat, organized report that a human can actually understand.
And just like that, all that complex data gets turned into a simple, clean table like this. Now you can actually see the story unfolding. Look at how the water uptake and leaf area increase from day 1 to day 3, and you see the total biomass just takes off. This is where a flood of numbers becomes a real, useful story.
But it doesn't stop there. It boils everything down to the absolute headline numbers for the entire life cycle. In a split second, you can see the total water used throughout the grow, or check out its water use efficiency, basically how much crop you grew for every drop of water. This is the ultimate big picture view.
Okay, this is all super detailed, super cool. Which leads to the big question. Why? Why go through all this trouble to build a digital plan? Well, this is where it all pays off in the real world.
Because the benefits are just huge. Imagine testing a new nutrient recipe without spending a dime. That's optimizing growth. You can predict exactly how much water your crops will need next week, which saves a ton of resources. You can basically see into the future, forecasting how a sudden heat wave might affect your harvest. And maybe the biggest one, you take the risk out of farming by trying out new ideas digitally before you spend real money on them.
And that kind of brings us to this really big final thought. We just walked through how to build a digital twin for a single plant. If we can do that, what comes next? What does this mean for how we understand, manage, and maybe even partner with our entire natural world?